Material for today you can actually find on the GitHub, so if you want to take a picture of this and if you want to get the code or the presentation itself, you can see it out there. This presentation was also made with R Markdown. It's another cool thing about R. And I'm also a part of the R Ladies. Yes, I'm a co-organizer. And you can also find us on meetup.com. Also, you can follow our Twitter. I try to do my best, but I'm not really good with Twitter, so I try to share the news as much as I can. But R Ladies is a worldwide organization to promote gender diversity in the R community, and it's a really actually cool community of women, and they do really amazing stuff with data analytics. And I'm really actually proud to be a part of it somehow. All right, so there were a lot of talk about data science, and I just want to start with just to give my sense, although, I mean, I'm just a PhD student, who cares about my sense maybe, but I just still wanted to put it out there. I actually tried to see, what the big analytic guys were saying about data science. I don't think, no one really gives a good description about what data science actually is. So it's kind of like, okay, so maybe it's anything you kind of do with data and just anything you can extract out of it, but it should be an information. It should be something informative, right? So even though description is kind of difficult, the workflow is more or less the same. And I think this must be kind of familiar to you from a previous presentation from Kelly, and this is really used like in the R world nowadays. This is from Hadley Wickham and Gail Gorman. Those are the two guys that are really driving this R movement, in my opinion, and they're both working for our studio. But this is the typical project workflow. So especially for R, we need to first import the data. So it can be different types of data, so we need to think about that first. And then we need to clean it, right? So we need to tidy it. And then potentially we transform it for the analysis that we want to do and visualize it and model it. And then actually here, there's a circle. And this is where the exploration kind of happens. And then out of that, we try to communicate our results. We try to tell our story. And R actually has a bunch of tools, and I will come to that again. But since I just mentioned big data in my sentence a little bit too, so that's another super buzzword and super blurred definition, I think. And this is like really famous words from the Dan Riley, I think that's how you read the last name. Big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they're doing it. That's actually a pretty good one, in my opinion. But so, this is another description from the data science department at Berkeley. And they basically claim that it should be the scale, it's the scale of data that matters. And then they say it should be terabytes to petabytes. And if you're just wondering, petabyte is 1,000,000 gigabytes. So then you can think, oh, am I really doing big data then? Maybe just take a moment there. But then there's also a better description, I think, from Hadley Wickham. And then actually he says in traditional analysis, the development of the model takes longer than actually analyzing the data. And with big data, that's actually the other way around. So when we try to apply the model, that takes actually longer. And just to be clear right now, R can easily handle data sizes up to like hundreds of megabytes, and additional R packages can help you with tens of gigabytes, and some even larger data sizes depending on the big data problem. And so then you can kind of ask yourself, is your big data actually big data? And this is again from Hadley Wickham, and I will show that book again too. But small data in disguise, basically suggesting that the thing that you're really interested in and answering, the data that you really need from that huge chunks of data, is actually a really small part of it. And you maybe are not necessarily dealing with big data in that case. And also another one is a large number of small data that is making up your big data. So although the data might be big, you actually apply millions of the same model to the different parts of the entire data, which is really common, for example, for statistical genomics. That's what I do. So for example, we have 9 million variants, right? It sounds a lot, and then we have thousands of patients. But what happens is we usually fit a model to each of the variant. So we actually analyze only maybe 6 or thousands of patients, still relatively big, but not that big. You don't need to deal with that 9 millions of variants all at the same time. So they all tested independently, and that's actually exactly the example of this kind of data. And in that case, you actually have, again, different platforms like Hadoop and Spark and SparklyR, and Kelly kind of mentioned, talked a little bit about that. And potentially you can, again, use those other tools to deal with that and still use R. All right. And why R is so awesome It's actually exactly because of this. So there are just so many tools, and this is a very limited, actually, selection of tools. The tools that kind of are part of the tidyverse, and I will come to that again. But this is like the new wave in R, and these are the people developing these packages are really close, related with the R Studio. And you can see that for importing, for example, you have a bunch of packages, and you can deal with Excel or even SPSS or SAS files. Those, for example, are handled by the Haven. And then you have Tidy, which we'll talk about today. dplyr again helps you, gives you a bunch of functions to transform your data. And then Broom is actually to clean up the output of your modeling, not necessarily help you model, but obviously R has a bunch of other modeling tools. And then Visualize, of course, ggplot2 if you're familiar with R. And then for Communicate, I think this is also where it gets really crazy. And I'm really, I don't know, I get really excited about this, that there's so many things out there. And even this presentation itself is basically an R Markdown, and I can just turn it into a presentation really easily, and I can show my code, and I can, just plug in interactive stuff in there and whatsoever. And you can even write a book with Bookdown. You can do interactive visualizations or dashboards that, that was really crucial for the opening talk, right? With Shiny. Even you can write a blog with the Blogdown. So there are really lots of tools out there, and this is a really, and it's all open source. So it is all free. You don't need to pay for a license that actually hooks you up, and you have to pay it every year because now everyone just learn how to only use that one specific software, and you need to just keep paying for it. Well, that's not the case for R. So that's actually another good thing, and that's why I think it's so powerful and has this really amazing community, which I'll come to again. And you can also do other cool things like animated plots. So this is from a GG Animate package, for example. And and I can just embed this here in my presentation. It's really cool, and you can see the change over time. Or you can even make interactive plots, and I just put my code in here just on purpose because it's so easy. Like, it's incredibly easy. Iris is just a data set already in R, and literally just put it in ggplot, assign it as a variable, and then you can put it into the ggplotly function, which allows you to actually have it, this nice interactive thing. And you can zoom in, you can zoom out, whatever. You can show multiple things at the same time. It's pretty cool, and it's very easy. So the purpose of this talk is actually to encourage you, if you're not already using some sort of a coding platform, potentially choose one, potentially choose R. Or if you're not familiar with R, make you a little bit familiar with R and feel you comfortable. So it's going to be pretty basic. I'm just going to demonstrate some of the functions that are available to you for cleaning, the really basic steps of data cleaning. And also, like I said, R has an amazing community, and you can check the hashtag #RStats on Twitter. And these are the people that contribute a lot, especially Hadley Wickham over here. He's like one of the main guys. But yeah, I see a lot of familiar faces here. I hear their names all the time. It's definitely a close, kind of a, closely knit community, actually. And that I think that's what makes R really powerful as well. All right. And so if you want to learn more about this, by the way, there's so many available resources out there. And I think definitely one of them is this R for Data Science book. So here it is. So you can literally just Google it, and I'm sure this will just come up. And here's the book. You can also buy it on Amazon if you really like a hard copy of the book. But I think the online book itself is really amazing. And honestly, most of the things I'm showing you today is either taken from this book or the vignettes that were written by Hadley Wickham or Gerd Kornland. So nothing that crazy, really. I'm kind of, almost copy-pasting here. So it's really easy to find anything you need out there. All right, and then the other one, actually, that I want to talk about is the tidyverse. So this is, again, I think this movement, I think it should be called tidyverse movement, actually. But it is a whole bunch of R packages that are really designed for data science and allows you to actually make your code more readable, and it's easy to understand, and the function names, for example, make sense, and then the arguments make sense. And if you want to learn more about it, again, you can go to the tidyverse. I'm sure if you can Google it, you will see it. But if you don't, it's just tidyverse.org, so it's pretty easy. And it has all sorts of suggestions. See, learn tidyverse. Here's the book again. And you can just see some other articles. You can see the packages that are actually involved with this tidyverse. And you can easily install that in R and just call the library very easily. And then all these packages will be available to you in your environment. Oh, and then this other one, of course, since Hedley Wickham thought a lot about these and been developing these tools, he also has this nice Tidy Tools manifesto. Again, you can find it in the Tidyverse. And I think this is actually another cool one. So if you have time, just take a look at it. And so today I will be talking more about this blue part of the whole workflow here. So it's just about the wrangling the data, basically, because it never comes clean and blah blah blah. So here it is. Here the data doesn't come clean. Yeah, pun intended, and requires cleaning before any modeling or visualization. Most of the time, people complain about, oh, the plotting is so difficult, I can't plot this, I don't understand the error, what's going on? Well, it's probably because the data is not in the right shape or form. So, and I really like these quotes from Hedley Wickham. I guess he took it from Tolstoy, and then he made it one for himself, and it's definitely true. So the tidy data sets all look more or less the same. They have a, kind of a similar format, but, every data set that is messy can be messy in its own way. So you need to do a bunch of different things to really clean them specifically, whatever the problem is. So that's why today I will be talking about tidyr and dplyr. Okay, so what is tidy data? A data that is easy to model, visualize, and aggregate. I think we can agree on that. And then a tidy data is where the observations are the rows of a data frame. Can everyone see from back over there? And variables are the columns of a data frame. And the data frame in R is basically like a matrix, but the variables basically come from different data types. So it is a rectangular data that we're talking about here right now. And of course, the values then are the cells of a data frame. Nothing complicated, it's pretty easy. All right, so since it's pretty easy, do you think this data is tidy? It's a very simple one, right? Well, we have to first think about what are the variables in this data? And then what are the rows? And then what are the columns? Well, I would say that the variables are actually sex, pregnancy, and N, which is kind of a hidden variable, right? But it's actually the counts. And so the rows are actually the values of a variable and not observations in this case. And the columns are then the values of a variable and not variables. Okay? Does that make sense? So a tidy version actually would look like this, right? Because then you can do something with this data now. And rows are observations, and columns are variables, and so the values are basically the cells of the data frame, right? Any questions so far? Nope. Yeah. So, and real data sets usually come with the following problems, and I will go through those. I will try to do my best in the next 20 minutes. So the column headers are values and not variable names. That's a very common one. Multiple variables are stored in one column. The variables are stored in both rows and columns. Multiple types of observational units are stored in the same table. Well, that's a kind of a questionable one, but still I will just show an example. And then another one is a single observational unit is stored in multiple tables. I bet this is a really common one too, where you have your data actually split into a bunch of different files. So now let's look at some tools from Tidyverse that can help with these issues. And then I will actually go through dplyr and tidyr vignettes. Some of them are a little outdated, so I edit my own splice just a little bit for some cases, but if you really wanted to see this for yourself, you can totally go and find them. Okay, so let's start with the first example. And the data set we have is Pew. It's a CSV file, and it comes from a report produced by the Pew Research Center, and it explores the relationship between income and religion in the U.S. And this is the head of the data, so it's rectangular, you can see. And then here on the left side, we have the religion, but the columns are basically the income for the people. And again, what we can say, this data is not clean, right? It's so obvious that the variables actually are column headers in this case. So this data has three variables, again, very similar to before, and what are they? So we have religion, income, and frequency, or the counts. And to tidy it, we need to actually gather the non-variable columns into a two-column key value pair. And what I'm going to do for that, or this is also really often called making a wide data set long, or melting, because there was actually another function in R before called melt. And actually, but now I think you can use the gather one because it's the new Tidyverse version. But we can easily gather the columns with the gather function. And the gather function has four main arguments. It's a data, and then the key, which will contain the collapsed column names. Obviously, they need to go somewhere, right? And then in this case, we will call it income, because that's what it is. And then we have the value, so it's actually gonna, whatever those were in the cells are gonna be populated under that one column. And in this case, we will call it N. And then we can specify the columns that we wanna gather. So it's a really amazing tool. Like, I can't even imagine, like, I don't know, like, what would you do if you didn't have functions like these? Like, I don't know. It's like, it's really annoying. So here's an example function for that. We have the data as pu, that's what we had from before. And then the key is our income. This is the new column name that we're giving. And then n is, again, our new column name. And then I'm selecting the columns anything other than religion. Pretty easy, right? And you're coding already. Like, if you try it yourself, you will be like, yes, I'm coding. So that's how easy it is. And if you use the pipe, it would look like this, and I will come to that again, but actually pipe makes your code look much cleaner. So normally in R you would need to put things in brackets and in parentheses all the time, and it gets kind of confusing. Pipe actually gives you a feeling of workflow, where I start, which function I use, how I transform it, how I move on to the next one, and what is my output. And in this case you can see that my data, pu, is getting into the gather function, and it's coming out of it, and it's going into the header function, so that it only shows me the first 6 rows of the data. Makes sense, right? Super easy. All right, and then this looks like this. It's all the clean. Oh my God, we went from this. We have so many columns, so ugly. Look at that. To this. It's only one line. So, and then this form is tidy because now it actually follows those rules, right? Each row is an observation of a demographic. So maybe not necessarily the individual, but a demographic. And then we have the n related to it. And our variables are basically our columns. So awesome. So let's look at the next example. And this is going to be from the Billboard. I think that's actually a funny data set. And the Billboard data set shows the records, the date a song entered the Billboard top 100, and rank of the song each week after that up to 75 weeks. Ugh, tough, yeah. It has variables for artist, track, date, entered, rank, and week, plus the columns from week 1 to week 75, okay? So this is like horrible. I'm obviously only showing the first 3 columns and the first 3 rows and first 10 columns of the data set. Here's the Billboard. And you can see the year, artist, track, time, date entered, and then from week 1 to week 5. But obviously this goes up to like 75. And yeah, that's maybe easy to just, useful for storage and whatever, but certainly not going to work for plotting or modeling. If you try to ever plot this data, no, that's definitely not a good idea. So again, we will actually go with the same workflow, right? So we will try to first gather these week columns. And then we can see, again, the data is coming into the gather. Now I didn't put the argument names. So before I was actually giving an argument and equal to whatever. But actually, if you follow the same order, you can basically do the same thing without giving the actual argument names. So in this case, I'm just gathering it, and I'm just calling the new column that all those weeks are gathered to is week, and then anything that is here as the rank, this is my new column. And then I can say that I'm selecting all of these columns from week 1 to week 76, and I'm also removing the NAs. So because why you want to keep it? And even if you would need at some point, you know that it goes from 1 to 75. So yeah, there's that. And yeah, and then I'm looking at my head, and it looks very nice and clean, right? This is so much easier to handle with there now. And yeah, so I just use this NA remove argument, just to remove all of the NAs. So again, incredibly easy. No wasting time. It's already made for you. Just use it. And again, don't be scared of coding. It's actually not that hard. I mean, especially if you need to do this for things like this. It's pretty easy, as you can see. All right. So we can also do a little bit more cleaning. So what I want to do, actually, instead of keeping these, here we have the week, but potentially you want to use it as a numeric variable, right? And I want to just extract the numbers from it. So there's a really cool function called parse number. It literally just takes the number out of, whatever string character that you have. And it makes your life really easy. Like, you don't need to deal with, regular regressions or, regular expressions or whatever. It just really takes out the number. It's actually a pretty amazing function. And then you can also use the date as date, so you can turn it into your date, and then you can actually add the week and multiply it so that you have the right dates for each of the weeks after that first week. Does that make sense? So you can have a specific date, which rank that was for that week from 1 to 75. And it's pretty easy because now that you have the date variable, it's very easy to manipulate, do anything you need to do with the time. And then so we actually remove the date enter then, and then we actually have the specific date for whenever that song was ranked in the Billboard Top 100. Yeah, makes sense? Yeah, and then it looks like this. Again, only took a couple of lines, and your data looks so much better than what you first started with. And finally, you can sort the data. That's not that big of a deal, but yeah, of course, why not, right? It's probably a good thing, so you can see the first things first, whatever you want to see. And you can do that very easily, again, with an arrange function, and you can specify which columns you want to arrange it by, and so on and so forth. And so, for example, if you would sort it by date and rank, here's what we see. I guess there was a person called Lone Star. I don't know, maybe I'm too young for this or something. I shouldn't be, but I don't remember this person. And I guess he or she had a song called Amazed and was in the top 100 for a while. But yeah, so there you go. All right, so another problem is then multiple variables stored in one column. And so that can actually happen after you gather the columns. Maybe you have a bunch of different columns that are actually specifying different things, but then once you gather them, they're all under one column, and you actually potentially want to spread them again because they're two different things still. So you can, for example, have week and, I don't know, I can't think of something right now. Oh, shoot. But, sorry? Quarter, sure, yeah. Yeah, exactly. And so, and in that case, we would need to actually make it wide again. So in this case, we're using the tuberculosis data set, and my code is kind of messed up here, but okay. So it's from the World Health Organization, and then it is counts of confirmed tuberculosis cases by country, year, and the demographic group. But the demographic groups are so weird. So as you can see, it's like males and females, and the range of the age, and all of them are columns. This is like, it looks very ugly, right? All right, so what we do, we first gather it, and then that's great. It's again exactly the same thing. And then we have a demographic column right here, right? And so we have the ends, but then we also would like to split this demographic column potentially. So, well, I guess it depends on the case. In this case, we don't necessarily have anything between them that actually allows us to really see, but we can still give the specific width for that. So, and again, that's super easy. You don't need to, for example, deal with that weird stuff in Excel, which would probably mess up your data anyway. So, and very easily, you can just take the data that you just transformed to separate, and then you can separate the demo column into sex and age after the first character, basically, because we all know that it always starts with the sex and then the age, right? So, and then now the head looks like this. So much cleaner now, right? So the variables are the columns, and then we have an observation in each row. Yep. And yeah, and then there's some other notes. It's like, yeah, you would probably not want to just see the count, but you want to see the rate. It would have not been possible before because you didn't have it in the right shape, etc., etc. But I'm sure you can fill in the blanks. But yeah, this is the type. This is the format that we want to basically have our data in. All right. Then another problem is that the variables are stored in both rows and columns, and this is the really messy data sets probably look like that, so they have both of the problems basically. And then for this one, I will be showing the weather data set, and this is the daily weather data from a global historical climatology network for some weather station in Mexico for 5 months in 2010. And so this is how the head looks like. And again, I cut it out because you can get the feeling that these days are actually days of the month, and then they literally go from 1 to 30. Again, oof, no. And then we have this weird column called element, which actually stands for temperature max and temperature min. Oof, yeah. you want to deal with that too. All right. And then exactly. So the variables and individual columns are the ID, year, and month. And then the spread across columns are the days. And then across rows are the temperature min and temperature max. And months with fewer than 31 days have structural missing values. So it's just going to be NAs. And then you also still have a bunch of NAs, a bunch of missing data in between as well. All right. So it's, again, a very simple one, right? We start with gather. Woo! And we basically, again, take our data set and plug it in together. It's a very similar one again, right? So my new column that actually has the days is going to be called day. Whoops. Sorry. Days. And then you can you see my my mouse? Yeah. All right. And then a value is just a value. It's probably the temperature at this point, but we actually need to deal with that later, right? And then I'm just saying from day 1 to day 31, just gather them, remove the NAs, and you have the weather too. And then it looks like this. Very easy. So at this point now I need to keep cleaning because my elements are basically 2 variables that are in the same column. So now I need to actually spread them again. I keep going further, yeah. And yeah, again, I'm removing the NAs, and then, if you really need that kind of data, well, you can figure it out because it's, it's the day of the month. So with more cleaning, what we can do is, again, we can extract the number of the day. Then we have a numeric variable, so we don't need to deal with the strings anymore. And then we can select the columns that we really need, and then we can basically arrange them, and this is how they look. Okay, nice. Now we have the days as numbers, but we still haven't dealt with the temperature. All right, and for that now we actually use the spread function, which is right here. And spread works very similar to the gather. It's just the opposite movement, opposite function basically. So in this case, we actually the key gives us the new column names, and then the value basically determines how those columns are going to be filled. Very easy. And in this case, I can just say, yes, the element is going to be spread out. And you can see that I have now ID, year, month, day, and then temperature max and temperature min. And now it's so much nicer. And I can actually go and do something with this data now. Yeah?
Sorry, quick question. How would that work if the temperature max and temperature min were if there was a couple cases where they were the same for a day?
Let me think.
You're splitting by the value. If the value's the same, might break your data more.
I don't think it should have any problems, but yes, you need to be mindful about that. Like if the rest of the data set actually has exactly the same values, that cannot actually discriminate where it's going to go, that could be a problem. I'm just thinking about it, and I think it can still handle it. I would need to see, reprex or something like that too. I should try it myself. Do you have an idea? Yeah, I'm not really sure, but I think it can handle it. Yes. All right. That's a really good question, by the way. You should be mindful about. We should be totally mindful about that stuff, or like why if you're getting an error, you should be like, that doesn't make sense, or try to at least read your warning messages when R tries to communicate with you that something's actually going wrong. All right, here we are. Okay, real quick, 10 more minutes. Right, 10 more minutes. Is it good actually? I don't know. Yeah. Okay. So then one before our last example is the multiple types in one table. Well, this is actually questionable because in most cases in R, if you want to do the analysis, you usually need the full data set to actually work with for most functions. It might really depend on the function you use again. There are a bunch of different objects out there. I'm just not getting into those stuff necessarily at this point. But this is just an example if you ever wanted to actually split your data potentially and just make an identifier. And again, we're using the billboard because if you remember, the billboard had a bunch of data sets, a bunch of data specifically about the song, but also where the song is at a specific week. So instead of keeping all the data about the song itself, we can have it as a separate data set so it doesn't repeat in each of the rows. And then there would be just its own data set, and you can deal with it just by itself if you ever need to. But if everything that you care about is just the ranks, then that's okay to have them separate. So that's what we're going to show here. And let's remember our billboard data set real quick, right? And this was our head. So this is the data we already cleaned. And there's 3 doors down. I know them. Like, that's a good one, I guess. I actually really like these songs, like the Kryptonite. Yeah. And then, so we will break it down to 2 pieces, and one is going to be the song data set, and then the other one is going to be the rank data set. And so we first extract the song data set. It's again pretty easy. We can use the select function just to select the columns, and again I'm piping. This is very easy to follow, right? So the data gets into this function, gets out of that function, and then moves on to the next one, etc. So if you're already coming from some other programming language you're probably used to, kind of wrapping your head around pipes. But R didn't have this for a while, so this is actually a godsend. So maybe you don't appreciate it just yet, but if you'd worked with base R, you would. So basically we just select these columns that are really specific to the song, and then we unique them. So because they were actually repeated before, because they were for each of the week that was still in the billboard, right? And now we can also mutate and just add like this ID that is going to be unique for that song, and then we can use that identifier and add it back to our rank data, and then that's actually something that doesn't take that much space and it's kind of cleaner, etc. So this is how our song data right now looks like. Right, so we have the data for the song, and then we have an assigned ID that we just assigned. You know, it could be just anything. You could also, if you really wanted to, I wouldn't suggest, but if you want to, you could use letters or, just add zeros in front of the numbers. Go crazy. But probably the easiest thing is just giving a number, right? So now what we need to do is actually we need to map all of these IDs back into the rank data, right? Because we already have those other things about the songs that are repeated in each of the rows. So instead of repeating all of that information, we're just going to repeat the song ID, which is a much simpler variable in this case. So what we're going to do is we're going to use this left join function. And what it does is billboard 3, so that's the one we already started with, right? So it's right this one, so just go up a little bit. So this is what we had before. This is what we started with. And what we do is that we actually add this new data set that we created with the song IDs. And we are using all of these artist, track, year, and time columns to map and add this new song ID column to it. All right? And that's actually, I think, a very powerful thing too. And I think it's a very common mistake if you don't do these merging stuff. That's something you should be very careful about. I think a lot of the mistakes happen a lot when you're actually merging 2 data sets. But yeah, it is very nice because the left join basically tells us that whatever is on the left side, which is in this case is the billboard, right, is on the left-hand side of the function, and we will keep anything that is already in that data set, and then map anything that is available in the song data set and add that extra column, because we already know that all 4 of these columns will already exist and will be just used for mapping. Right? Clear? Right? And then we can select then the actual columns that we need and then arrange it by the song ID and date, and then here we go. We have a much simplified data set, and we don't have all that extra information about the song and the artist, etc. anymore. But it's already kept safe in a different variable and it's as a separate data set. All right. And then finally, the last one. I'm good on time. It's another common thing is that you have your data basically spread out to multiple files. And what you need to do is basically read all of the files into a list in R. And I know I didn't get into like the actual classes and data structures in R, but you can learn all those stuff again yourself. And there's just so many resources out there if you are not very familiar with them. And yeah, anyways, so we're basically reading all of these files into a list, and then for each table we will add a record of the original file name, and then combine all of the tables into a single table. Okay? All right. So I will use the map function for this, and that's in the per package. So if you remember when I was showing all of those R packages, the one with the little cat, it was in the middle of the iteration, because per actually allows you to do it allows you to do a bunch of iterations basically. So it's kind of like a for loop, but not messy as a for loop. And so the following code, I will first. I actually generated a bunch of chopped up iris files and saved it just for demonstration purposes. So what I actually first do is I get the file names from my directory. So data is my directory, and then I can use this pattern, and then it basically lists all of the files that I have in that directory with that specific pattern. And I want the full names for it. Awesome. And all I need to do, literally, look at this. This is one line. This is one line. This is mapdf. So it basically applies whatever function you need on a specific set of list or a vector. So in this case, it's just like the actual directory or the path for that file. And then I'm applying a read tsv function. And look at this. It's already done. It's already in a data frame. It's already in that nice rectangular shape. Well, of course, you need to make sure that each of the file have the same header, obviously. So if you don't, well, you need to use the previous tools that I just showed you, right? But still, it's one-liner, right? But I said I will also add the file name, and well, I couldn't come up with something better, so I had to write my own little function. But again, it's super easy. So there's this one cool function called base name that actually just gives you the name of the file instead of the entire path. So it just allows you to extract that, which is, I think, super useful. And here I'm just writing my own function called read files. Again, super easy. I have the same function that reads the data in R, right? And then I pipe it into a mutate function, which will add this new file name as the base name. So basically, whatever that path that I have will be read into R, and then I will extract this base name and add that as a new column. And then I again put that into the magical mapdf function, which basically applies again this function to each of the elements of whatever you have, which is paths in this case. So it applies the read files function to the paths and turn it into a data frame. And then ta-da, I have all my columns, and then here on the right I have the file name. I think that's really powerful. Yeah. Yeah. Yeah.
What happens if the column headers are different?
Well, then you need to write, like, it's the same quote I will repeat again. Every messy data set is messy in its own way, unfortunately. So you'll potentially have to go back and clean them yourself one by one. Or you can apply the dry, right? Do not try to repeat yourself. Don't repeat yourself. Yeah. So you can try to come up with a code that actually does that kind of in an automated fashion for you. But again, it will really be really specific to the problem that you have. Yes?
Does that work if someone gives you like an Excel file with different tabs and it's all the same data? Like, can you?
Yes. I think, so by tabs you mean like the Excel? Yes. So there's a read Excel package for that actually, and I think, and that's again a super powerful thing. And where did I have that? I think I showed it why R was so awesome. Yeah, so here are the packages. So read Excel, for example, and it just makes me really funny, make me laugh, because the clip I think looks sad, and I think that's like the Excel is like the nightmare of many data analysts. So it's kind of to the point in my opinion. But yeah, so you can definitely do that stuff with a bunch of different packages in R. Yeah. Yeah, I'm actually done with my talk, by the way, so I'm happy to take any questions that you have. Yeah.
Is this going to be available?
Yes, so maybe you can take a photo of this. I already put it up there on my GitHub, so you can literally just go here. And don't be afraid of the GitHub if you're not familiar with it either. Like, you can literally just go to the link and download the file. Like, there is a button to download the file, so it's all good, you know? Yeah, any other questions? I mean, I hope this was a good, demo for you guys to just, feel comfortable that you can get into this world if you're not already in it. And I think these tools are really powerful. And if you try to do this, I think, and obviously you can, probably do it in Python and whatever, but I'm not sure if it would be as easy as these. So, I just wanted to show you that it is really easy, and these tools are available, and there's a bunch of resources out there that you should get excited about, especially if you're in the analytics world. I think this is such a, nice moving movement. Actually, it's kind of a grassroots movement. I don't know, I really like it because I think it's open source maybe, and then the community is so strong out there, and the social media, it just really gives me the, motivation to really keep working with us. All right. So no other questions?
What kind of events do you have at Arlie's Columbus?
Oh yeah, sorry. Yeah, so unfortunately we haven't been very good, and we haven't had a lot of events lately. We were traveling and so on. But if you are already in R and you want to present something, for example, please approach me. I also have a couple of R Lady stickers, thanks to Kelly, because I'm a horrible organizer. I never ordered it. But, still, we have them. So, and if you're interested, of course, you're always more than welcome to our meetups. We'll probably have one soon. I'm probably going to show some data visualization with like ggplot. And again, I will assume that your data is clean, so I will assume that you can do some manipulations beforehand. So, yeah. But yeah, so actually, if you're from Columbus, maybe you did hear about it, maybe you didn't. I actually tried to hold a couple of workshops in the last summer to raise some money for Pelotonia. I don't know if you guys are familiar with Pelotonia, but it's like the cancer fundraising. And it was actually really good. So there's definitely a community that is really interested in this. So I would love to just come together, just really approach to me, just, send a message on Meetup or whatever you need. And yeah, we try to meet basically every month. That's like the aim. But I think we'll be better. We have plans to actually go through the R4 data science book. And we also want to just hold sessions as like a Q&A. So if you're familiar with Stack Overflow, kind of like a Stack Overflow. So if you can bring your own RIP racks and, we can try to solve your problem kind of on the live. I think that would be a fun thing, actually. And it would be a good example for everyone because usually everyone has the same problem. So, yeah, just keep looking at our website. We'll probably come up with some new stuff, yeah.